Alright friends, hello, welcome back to Scriddle. This is Scriddle 10. If you don't know what Scriddle is, I recommend you go and watch the video for Scriddle 9. I won't go over the whole thing now, but the short version is that we're going to solve a puzzle without knowing what its rules are. And every time we guess at the solution, Scriddle's going to tell us which rules we got wrong. So it's harder because we don't know what the rules for the puzzle are, but we have this oracle we can ask and it will tell us how close we are to the solution. So go watch Scriddle 9 if you want it more walk through. This is me solving 10. This is the first time I've looked at it basically. And what are we looking at? We're looking at grid with circles on, I should say. This is immediately making me think of the queens, the n queens problem in computer science, where you have to place a bunch of queens on a chessboard so they can't see each other. It's also making me think of, there are a few puzzles I've played like this where the sort of connection points between circles is important. And it's also notable that there's sort of 3 black circles and 9 white ones. So it's not like that there's an equal amount or anything like that. And of course the big question that we haven't tried yet is what interactions do we have? Is this shading? It is shading, but we can shade the dark circles, but not the white ones. That is interesting. Okay, so we can paint loads of squares if we want to. I think it's really weird that we can shade the black circles. I don't know how I feel about that. So what could it be? It can't be about sightlines because these two already see each other and we can't stop them. It could be about the black square sightlines, but that would be a pretty easy puzzle to solve. Could be about penning them off. Like maybe you need to create like an area with an equal number of like black and white cells in. Could be something like that. Let's try that. Let's see what happens if we do that. Okay. Okay. So looks like the red cells want to be in the same bit, the same pen, I guess. Well, actually, maybe they just need to be connected. Maybe it's more like that. But let's have a look at this orange one, because the interesting thing is that not all of the grid is failed. It fails the orange rule. So what's going on here? What's the difference between that bottom bit? Could be that it's square. Could be that it's only got 9 cells in. So it could be more about like the size of the penned off areas. Let's see how it likes this. Okay, interesting. So, if that was too quick, this actually respects the red rule now that we've connected the blacks to the shaded area. So I've got a theory about that, we'll get to that in a sec. Now everything breaks the orange rule, which is interesting. This does lend some credence to the theory that like the shape or size of this grid was important. And we've also broken a new rule. This one looks kind of obvious, right? It's similar to Scriddle 9 where can't have 2x2s basically. This is looking for like a long snaking path. So I think what's significant about the red rule here is that basically, and again, I talked about this a little bit in number 9. When I'm trying to solve these, I'm thinking about like, if I knew the rules of this puzzle, where is my starting point? Like the puzzle is designed to have a place where the player's attention is drawn to first. And it seems like these black circles have to be in the shaded area. It's almost like they're fence posts, right? So I'm going to draw a fence on this map, and the black circles have to be posts in the ground. And that gives me some kind of starting points where I might think like, oh, well, these need to be connected, so maybe this is quite likely to be a square. So 9 white circles, and what is this grid? This is an 8x8 grid, 64. But then I can put a variable number of shaded squares down. So I'm thinking that maybe it's more like the pens have to be equal size. Maybe that seems more plausible to me. It does feel like it wants. I think 2 pens would be plausible. Like cutting the field in half. 4 would not be. For starters, it doesn't divide by 4, but also it even if it was like divide the square by 4, I don't like that one. So it feels like it's got to be 3 or 2. And the placement of this circle is really interesting because it's kind of awkward. It's kind of annoying. which makes me think it's there intentionally to make splitting these harder. So my theory is actually that it's got to be an equal amount of space for 3x3 grids. So what is this? This is 2x8. This is 16 squares. That's probably too many. This is 2, 4, 6, 8, 10, 12, 14. Sorry. 2, 4, 6, 8, 10, 12, 14. If we did something like this, but then now this is too small. So this is only 12. This would make both of them 13. We could do, would that count? Would that work? No, it wouldn't. But it does respect the other rule. That's, oh, because I'm an idiot is the reason why it wouldn't. Because there's not an equal number of circles in each region. But it does seem like we're onto something with the other rule. So this is kind of a bad design. I think we need to undo this. So assuming that 3 circles need to be in each area, this is kind of, this feels, I mean, this is rough. This is really rough. So this is 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, 13. So I've added 2 here and taken 2 away, which is actually not what we wanted. But I can fix that. So this is 2, 4, 6, 8, 10, 11, 2, 4, 6, 8, 10, 11, 12. Oh, okay, so this is fine. This was 12. And then this was 16, 17, 18. 16, 15, 14, 13. Ooh, so close. Am I being an idiot? Is there an obvious thing to do? Oh yeah, I can do this, right? So this is 2, 4, 6, 8, 10, 12. God damn it. I really thought I was onto something there. I was so happy with myself, let me tell you. Okay, let's return to this question here. What, oh, okay, we've actually always broken. No, we didn't. Yeah, okay, so all of my subsequent suggestions have broken the orange rule, except this one. Why would that be? It can't be that it's square. I don't think it can be that it's square. But it also can't be that it's a 9x9 area. 3x3 area. It can't be that either, or a 9. It could be that it's a 9 square area, I suppose. That's probably the easiest one to test. We should probably test that one next. Okay, so we can still do this. Oh yeah, see, we can't. We can't make it a. Or can we? Am I being stupid? 2, 4, 6, 8. No. Need to be like that. That's 9. But them just all being 9 feels like, and this breaks the rule actually. I mean, it can be something like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Do that. 2, 4, 6, 8. This would also be fine. 2, 4, 6, and then something like this. These are all 9, but this can't be. Yeah, okay. This is none of them satisfy it. Okay, so this is all right. Let's try something else. I'm being a bit. I think there's obviously it's very satisfying to get it on the first go, or to get it with a low number of guesses, I guess. But obviously that can also be a trap. So let's see. This is a square region. What does it think about this? It does like this. Okay. Unfortunately, there's 2 theories of why it might like that. It could be that it's square. However, it could also be that it is a 4x4 grid and it has 4 circles in. That was the other thing that occurred to me. The other problem with it wanting to be square is that I can't really. It really does make a lot of sense though if it's square. I think this will satisfy that. That's a square area. Oof. We can't make this a 4x4 unless, yeah. We can make it like a 2x2, and then what would this be then? Oof. Oof. This can't be a 3x3. It can't be a 2x2. This has to be a 4x4. It could be a 5x. No, it can't be a 5x5. This is also fine though. I don't think it's going to allow this. Well, let's see what it does to the orange rule. We know this is going to break the third rule, I think. Ooh. Okay, so it doesn't want regions where there are no things in are not allowed. But although this one was fine. Why was this okay? I wonder. Oh, because it's got none in. It's a square region with none in. That's really funny. So I can do this. No, I can't, because then it's not connected. Fuck. Okay, but I could do this. Nope, still can't. This? Ooh, hold on. Hello. There it is. We did it. Not bad. Not bad. That was an interesting one. This is so every Scriddle puzzle I've really liked for different reasons. The one I like about this is that I really felt like my understanding of the puzzle evolved very slowly. So at first you're like, this region is like, it's a 3x3, so maybe they want like all 3x3s or all squares. And then eventually you realize, yeah, okay, it's all squares, not all 3x3s. And then you realize like, oh, but that could be a square of 1. And then you realize, oh, but that could be a square with no circles in. And like as your understanding evolves, you start realizing that there are actually these nuances to the rules. So I think this is actually like a really cool example of like one of the ways in which Scriddle can be really delightful to play. Yeah, that was good. That was good fun. I hope you enjoyed playing that along with me. And yeah, I'm looking forward to doing. I think there's at least 2 more coming this month, so I'm really excited. Go play Scriddle, everyone. And thanks for watching.